So actually, we had done part A of this problem in the last video, and my internet got disconnected. But let's do this again. This is slightly different numbers. So probability of E complement. We said that E complement is whatever is not in E. So E has 10, 11, and 12. And our whole universe is 10 through 21. So you write all of these except the ones that are in E. So basically don't write the 10, 11, and 12. And it would be 13 through 21. And then for E complement probability, you count how many are in E complement and divide by the total. The total is what is in S. So I was mentioning the rule that the way to count quickly, you can just count them by brute force also. But if you just want to take a quick approach, so you do 21 minus 13, that's 8, and then you add 1 back. So actually it's 9. And then you divide similarly if you want to count how many are in the S. So you do 21 minus 10, that's 11. And then you add 1 back, so that's 12. So 9 over 12, which is 0.75. Standard deck of cards contains 52 cards. One card is selected, compute the probability. So some of you are not familiar with the deck of cards. So let's write down what you're supposed to know about the deck of cards. So there are 4 suits, which are diamonds, hearts, clubs, and spades. So the diamonds and hearts are red. In fact, what we can do is so diamonds and hearts are red, and clubs and spades are black. So each has 13 cards in it. So they are numbered 2, 3, up to all the way up to 10. And then we have Jack, Queen, and King, and Ace. So that's in all of the 4. It's like that. And the Jack, Queen, King are also called picture cards. They're called picture cards or face cards or court cards. So going back to the problem, calculate the probability of selecting a 2 or an 8. So there are 4 2s and there are 4 8s. So each suit has a 2 and each suit has an 8. So, and there is no overlap between the 2s and an 8, so you just add them. So 4 2s plus 4 8s, so that's a total of 8 cards out of 52. And then you find what that is. 8 divided by 52 is 0.154. And then compute the probability of selecting a 2 or 8 or 9. So similarly, there are 4 2s, 4 8s, and 4 9s. So that's 12 cards. So now you would do 12 divided by 52, and I think it's 0.231. And then king or a diamond, that's a bit different because there is overlap between kings and diamonds. Now, there was no overlap in the previous two parts because if you are, like here, if you're a 2, you cannot be an 8, and if you're an 8, you cannot be a 2, so they are mutually exclusive. But the king and diamond are not mutually exclusive because there is one king of diamonds. So here we'll use the main addition rule, which says probability of king. So there are 4 kings, and then plus 13 diamonds, and minus, remember, we also have a minus A and B. So we would subtract the common between diamond and king. So there's one card which is both diamonds and kings, and then we'll divide all that by 52. So probability of king plus probability of diamond minus probability of king and diamond. So there are 13 of each cards, like the 13 of each suit that I mentioned over here. So we have 13 diamonds, 13 hearts, 13 clubs, and 13 spades. That's how we make up the 52. And so when you do this, this is 16, and you have to divide it by 52. So 16 divided by 52 should be 0.308 in decimals.